I'm Sharut. I'm a third-year PhD student working at MIT CSAIL, and I am advised by Professor Stefanie Jegelka. The goal of my research is to learn representations from unlabeled data so that they align with the structures and the priors of the world. And I've been trying to do that from the perspective of contrastive learning. The world I envision for AI is a tool which augments humans in the ways that it makes their lives easier. Could be in terms of productivity, could be in terms of decision making. And to actually make these AI models more effective, you need to be able to have such models which can learn from tremendous amount of unlabeled data, which is all across the world present on the internet. So contrastive learning is one such paradigm where you can train models which learn from just unlabeled data specifically for images. So for instance, you are given large amount of unlabeled data. How do you learn a representation which captures how images relate to each other? For example, if there are two breeds of a dog, they are similar. So we want the representation to also capture such relationships. And what I'm trying to do is that make sure that this representation is rich enough in terms of semantics so that it captures these relationships which are present in the real world effectively. What you should be sensitive or insensitive to actually depends on what task you're in. To give you an example for clinical decision making, say you have a task of patient diagnosis and prescribing medicines. In that case, your decision really depends on the physiological characteristics of the person or the gender of the person. But if your task is to, say, predict the medical bill of a patient or like the length of stay of a patient, it should not depend on the gender of the person. We should have a fair decision in that case. So even in the same scenario, which is clinical decision making, depending on what task you have, you might need a representation which is sensitive to certain features while insensitive to the others, and vice versa. Self-supervised learning is learning from unlabeled data, but the supervision or the signals come from the data itself. For example, the PhD student is in the lab. What I can do is I can train a model to mask out certain tokens in this sequence. For example, if I mask out a student, and I can give the model the rest of the tokens, that is the PhD in the lab. So the model can get the supervision from the remaining tokens in the sequence, and the model will be trained to predict the masked tokens, which in this case is student. So because of the remaining tokens which are visible to the model, the likelihood of predicting the masked token as student is much higher. So the supervision comes from the remaining unmasked tokens. This is extremely useful specifically like in high-stake environments like say autonomous vehicles, or as we already discussed, like clinical decision making, because this leads to preventing like biases in your algorithms, which can make you trust AI decision making or AI driven decision making much more. And in general, this whole idea of having an AI model which can generalize across a range of scenarios without requiring like retraining each time, it's not just a useful tool. I think it's very essential for AI to actually scale for businesses and for masses, because no industry or no company would want to invest so much money if the model is not even generalizable or is not reliable in the first place. I'd say CSAIL was my #1 priority when choosing like to go to a grad school because of the mentors here, the whole culture of collaborating, discussing things together, and like of striving to do research which is actually very meaningful and impactful. The research is cutting edge with a lot of opportunities. You can collaborate with various industries in the area. And you can genuinely develop solutions which can create a meaningful impact to the society and not just confined to the research spaces.